Section 7.1 talks about invoices and trade discounts. You can think of trade discounts like sales. Okay? You might see something that's 10% off or 25% off, and then you want to figure out how much you would spend for the sale price. The first part of Chapter 7, Section 1 starts with these abbreviations that you might run into. So each dozen, a gross is basically 12 dozen or 144 items. Okay. Ones that we're going to use later in Chapter 7 are these bottom ones, EOM for end of month, ROG for receipt of goods, and COD, cash on delivery. Those will come in when we talk about Section 7.3 and Section 7.4 in another video. One thing that we're going to start with is we're going to start with calculating a net cost equivalent. A net cost equivalent is one of the first things that you're going to need to calculate when you want to calculate a sale price. Okay. So to get started, what we want to do is we want to calculate the percent to pay. So when they say this is a series discount, it means that you have two discounts, one right after another. First, you're going to have a 20% off, and then another 20% off after that. So these are the percent that you're going to be deducting from the price. Okay. What we want to look at is calculating the percent that you would pay. Since 100% is the maximum, that's everything, to calculate the percent to pay, we would take 100% minus the 20% discount to get our 80% to pay. And then with the second one, let me use a different color. That one's going to be 100% minus the 20% discount. So again, 80% to pay. And you're going to put each one of those discounts together. So 80% to pay times another 80% to pay. We can think of multiplication like saying of. We're taking 80% of another 80%. Okay. Now we're going to take each of those percentages and change them to decimals. The 80% that you pay is equal to 0.80. And we're going to multiply that by another 0.80. And we end up with a total of 0.64. Okay. Now keep in mind these were both percentages to pay, so the 0.64 is still a percent to pay. Only we use the decimal equivalent instead of the percent symbol. This is going to be the net cost equivalent. And they do want you to keep it as a decimal. However, you can think of this as 64% off of the original price. And that's really what the net cost equivalent is telling you. What is the percentage you would pay? And then it's the decimal equivalent of that. Let's give one more example like that question 1, and then we'll use it in an application. So question 2 shows that we have 4 different discounts. 25% off first, then 10% off, then 20% off, and finally 10% off. Okay. So we have 4 different discounts that would apply. You first take the 25% off, then after you get that total, you take 10% off that, then after that total, 20% off, then after that, 10% off. But we can use our percent to pay. So 25% off means 100% minus 25%. That means 75% to pay. Okay. 10% off, I'm going to keep showing the arithmetic that we're doing here. 100% minus the 10% discount gives us 90% to pay. So remember, we're doing 90% of the 75% amount. Then the 20% off is going to give us 80% to pay. And again, that's 80% of the 90% you had here, of the 75%. And then finally, the 10% off is going to give us 90% to pay. And I'm going to write in all of those ofs. You're going to have 75% of the 90% of the 80% of the 90%. And each of these ofs is our multiplication. And then we're going to change each of those percentages, make sure they're the percentages to pay, and we're going to change each of those percentages into decimals. 0.75, 0.90, 0.80, and 0.90. When I multiply all of those together, I get an answer of 0.486. Usually they have you go to 3 decimal places. So 0.486 is our net cost equivalent. And remember, you can think of this as 48.6% to pay of the original. So if you were able to get all of these discounts on an item you were purchasing, you're really only paying about 48% of the original cost. Let's start to use this in a few specific situations. So in question 3, before I get to it on the printed sheet down here, I want to show you what's happening. And again, you have to take one discount after another. So I'm first going to show you the long way. And it's just more steps. It still gets you the same answer. But I want to show you how it works. And then it kind of makes the shortcut seem so beautiful that you can do all the work in one step. So if you went to buy an item, so let's say you're going to go out and buy the most recent pair of tennis shoes for $148, but you get 2 discounts. You get 25% off, and then after that, you get an extra 10% off. Maybe it's family and friends weekend, or sometimes when you go to the register, they say, if you sign up for our credit card, then you get an extra 10%. So it is fairly common to get multiple discounts. Okay? So I'm going to first work with that first discount. So the long way is going to say, well, let's find that discount. What is 25% of $148? So I would take my 25% decimal, which is 0.25, times 148, and I get a $37 discount. Well, that $37 discount is discounted from the $148, so we would take $148 and subtract the $37 discount, and that gives us $111 to pay. But then they're offering you that second discount. So let me write, now we have a second discount. We're going to take that $111, and now we get 10% off. As a decimal, that's 0.10. And multiplying, that means we're going to have $11 and 10% discount. Now that discount, remember, is on the $111. So if we take $111 minus the $11, and 10-cent discount, we end up with $99.90 to pay. And that's where we'll stop because we don't have any other listed discounts. Okay. Over here on the right, I'm going to show you just a slightly shorter version. Okay. So I can go right from $148 original amount to the $111 to pay using that idea of what we call the complement. So what we were just doing right here, that if we said we had 25% discount, the percent to pay was 75%. So using that idea right here is where we're going to go. I'm going to start with 25% discount means 100% minus the 25% discount, 75% to pay. We can take that $148 times the decimal equivalent of 75%, and we end up with exactly $111. So notice that these are the same. Instead of finding the discount and then subtracting, we were able to find the percent to pay and then use one multiplication. We can do that again here in the second discount. Take the $111, and our second discount is 10%. 100% minus the 10% discount is going to be 90% to pay. As a decimal, that's 0.90. Whenever I multiply 111 times 0.90, I get $99.90. And again, that's to pay. The amount that you would pay at the register. Same exact answer, mildly fewer steps. But watch what we can do, and I'm going to scroll down here, same question, $148, and we're going to use the 25% discount, means 75% to pay. The 10% discount means 90% to pay. And we're going to do all of this work in one step. I'm going to take the $148 and I'm going to multiply by the decimal equivalents of each of our percentages to pay. 0.75, and then over here we're going to get 0.90. When you multiply all in one step, because you've already found the percentages to pay beforehand, we go right to the answer of $99.90. So this one's a lot fewer steps because sometimes we're doing these percentages to pay in our head and then going right to what amount you would pay. Let's try again, and let's use this shortcut. If you want to buy a $25 t-shirt, but you're going to get a 30% discount followed by a 20% discount, that 30% discount means you're going to have 70% to pay. The 20% discount means then you're going to pay 80% of what you had here of the 70%. Putting it all together, we're going to have the $25 list price of the item, changing each one of these to their decimal equivalent, 0.70 and 0.80, multiplying all together, our cost or our sale price is going to be $14. Okay. One last question to go through for section 7.1. In a word problem format, Roger is a restorative nursing assistant, an RNA, and finds that the list price, all the list price really means is the original cost or original price. So sometimes called the ticket price. Okay. We want to find the sale price or the discount price. Okay. 1 dozen, so that's important to remember that 1 dozen is 12. So the purchase of 1 dozen walkers is $1,680. We want to find the cost of 1 walker. Okay. If you get a series discount of 40% off, and then followed by 25% off. Our first step is to find the percent to pay. So if this is our 40% discount, 100% minus the 40% discount is 60% to pay. 25% off is then going to say that we would pay 75% of the previous amount. Now we're going to put it all together. Our list price, which is really the ticket price, of $1,680. We're going to multiply by the first decimal equivalent of the percent to pay, 0.60. Then we're going to multiply by the second percent to pay from the second discount. And I end up with $756. And again, I'm going to write this per dozen. And this is the amount to pay. To finish up our question, the last thing we want to do is find the cost of just one walker. So if this is per dozen, we're going to have to divide that by 12. So 756 divided by there's 12 walkers in a dozen. And I get that our final answer is that there's $63 for each individual walker. And that's the end of section 7.1.